Let's talk about transformations, more graphing, right? So back in chapter 2, we started graphing lines, and we also graphed some absolute values. We even graphed some quadratics back there, right? We're going to do that again. So in this entire chapter, we've been talking about quadratic equations. And we first, started working with this form, ax squared plus bx plus c, right? This is called the standard form, right? The standard form of the quadratic equation. Now, you can take that, you can, switch this around, and you can write it in different form, which looks like this. We call this the vertex form of a quadratic equation. We've seen that before, right? Ax minus h squared plus k. We saw this in chapter 2. Okay, yeah. Huh? No, I mean, you have to know what each of the different things does. So for example, this h here, do you guys remember what that h did to the graph? Okay, it moves the graph horizontally. So remember, if I have something like this, like y equals 2x plus 3 squared minus 4, let's say, if it's x plus 3, remember it moves to the opposite direction, negative side, right? So that h moves the graph horizontally, and you go opposite to the sign. Okay? Now, the k moves the graph vertically, right? So the k moves the graph vertically. Okay, and for this one, you go with the sign. Okay, so if it's minus 4, it goes down, plus 4, it goes up. Now, this a has two functions. One, if it's right, if a is positive, it faces up, but if a is negative, there is a reflection around the x-axis. So if a is negative, there is a reflection around the x-axis. But also, the value of a controls how wide or narrow the graph is, right? And we call that either a stretch or a compression. So if a is greater than 1, it's a vertical stretch, and the graph becomes narrower. But we don't say narrower, we say vertical stretch. If a is between 0 and 1, it's a vertical compression. Okay, so on your homework and on your test, you're going to be asked to use this information to graph a function that says if a is between 0 and 1, it's a vertical compression.
What does it say after reflection?
Around the x-axis. Sorry, I think the green was a poor choice. Okay, so not only are you going to have to graph using this information, you also then have to describe, and I have a typo here. This should say describe the transformations. Now on the chapter 2 test, more than half of you were calling me over saying, Miss Malikin, I don't know what this was. And that's how I knew you hadn't even gone over the practice test, right? Because it was all over the practice test. It's not going to happen this time because now it's our second time doing it, and we're now expert math students at this point. Yeah.
So there's no difference between this and what we did.
Chapter 2. Just review.
This lesson is mostly review. That's why I went so heavily into that then, because I knew it was going to come back. And then in this chapter, there's so much other new stuff. I just wanted you guys to have a good understanding, but yeah. Okay, so let's take a look at this. X, if a is between 0 and 1, okay, so let's take a look at this. X minus 4 squared, okay, the minus 4 moves the graph to the right 4 spaces. So the vertex will be at 4, 0 here. Now, at this point, you have a few different options on how to get some other points. Option 1 is plug some points. Okay, now, as opposed to before, we have like this knowledge of the axis of symmetry and so on and so forth. Remember, if the axis of symmetry is here, what were we doing at the beginning of this chapter? I said all you needed was 1 or 2 points to the right or to the left. So stick to a side and pick a point. Now here, I'm just going to require you to pick 1 point. So why don't we plug in a 4? I'm sorry, not a 4, a 3, right? So here you plug it in, 3 minus 4 squared. This is negative 1 squared. You get a 1. You mirror it on this side, and you get this. Okay, now, before I take questions, I'm actually going to show you guys a couple of other things. Okay, so first of all, when you are plugging this in, right, make sure, like put in the numbers, 3 minus 1, use the parentheses, right? Oh, I'm sorry, it was 3 minus 4. Right? Use the parentheses in the proper places so you get the right points. Okay, so here's what I want you guys to do. Go to the graph. Yeah.
So what you just did, that like you don't actually have to do them equals negative 1 squared, right? Equals 1, because you already did it.
Right. So in here, please put in this function, x minus 4 to the power of 2, or squared. Graph it, you should get this. Okay? So we know that this first point is at x equals 4, and we want another point on the graph, right? So do you see how here we're coming up with the table and we're plugging it in ourselves? Now here is what I want you to do. At this window, I want you to press Control, which is the blue button, and T. Control T for table. T for table. And when you do that, it gives you a table of values. So now, what number did I want to plug in here? A 4, right? I'm sorry, no, it was a 3. You're right. Sorry.
Oh, it's 3, 1. It makes sense.
Yep, it does make sense because it's math. So I wanted to plug in a 3. So here, you can use the up or down arrows to scroll up or down. 3, you get a 1. Okay? So that's another way that you can do that. Okay? All right, so now let's go ahead and describe the transformations. This graph, all it did was move to the right 4 units. That's it. Okay? All right, let's go ahead and do the next one. We have x squared minus 6. The minus 6 moves the graph down 6 units. So why don't we write the transformation first? Down 6 units. Okay, so my vertex is going to be over here at 6, at negative 6. So now I have to decide what point I want to plug in, right? So I have x and y. What's a good point to plug in? 1. 1 or negative 1, both will work. So it'll be 1 squared minus 6. And again, you know what? I don't want to take any chances. Yeah, you can just plug that in here. Okay, 1 squared minus 6. Negative 5. So here, negative 5. And then I mirror it on this side, and I get this lovely graph. I want to see 3 points exactly where they should be. Okay? Because this moved down. Okay. So let's take a look at this next one. Okay, so what does the 3 do? Move the graph where? To the left 3 points. So we say left 3 points. What does the 2 do?
It's the
Vertical
reflection.
compression.
It's a vertical stretch. It's a vertical stretch. Remember, it's the negative that makes it a reflection. This is a vertical stretch. Good. So now we all know on the test when I say describe the transformation is exactly what I'm talking about. Okay, so where is the vertex going to be? At what point?
0,
-3 comma 0. Okay? All right. So now what point am I going to check next? -2 works. Okay? So you either plug it in or you can go to the table here. Okay, how do you get rid of this table? We brought it in by Control T. You can get rid of it by Control T. So what I want everybody to do right now is you can erase this by doing Doc B. I want everybody to graph this function, and then I want you to do Control T and bring up the table. Right, so this is the function we have here, and if you plug in x equals, like, I don't know, -2, what was the y value? 2. And what about x equals -1? What's the y value then? It is 8. Okay, so, whoops. Okay, so on your test, I just need 3 points, right? It doesn't matter which 3 points you pick, right? But they have to be 3 correct points on the graph. Okay, let's do this next one. So the +4 moves it up, right? So it's moved up 4 units. What other transformations are on here? Okay, thank you for raising your hand. Now the next step is you have to wait to be called on just so I can get other people a chance as well, okay? All right, so there is a vertical stretch. This is not a compression, it's a vertical stretch because 2 is higher than 1, and there is a reflection around the x-axis.
Wait, how can you tell if there's a, is it because it's square?
The negative says there is a reflection. Okay, so the vertex then, it's moved up to 4. It's going to be over here. Okay, and you know what? This time I'm going to plug in a number. So here I have x and y. I'm going to choose x equals 1. So that will be -2 times 1 squared plus 4. -2 plus 4 is 2. Okay, you can also plug that into your calculator. So at 2, I have this, and I have this, and I graph, and it looks like this. Okay, so I am giving you so many different tools to be able to do this correctly on the test. Okay, all right, let's do a couple more. Oh, I forgot to put the lines for the transformations here. Okay, so the Maddie, where does this 2 move it up? What about the 3? To the right. You go opposite to the sign. Okay, you go opposite to the sign. Okay, Sam, what does the 1/2 do?
The 1/2 multiplies.
Right? It's a vertical compression. Okay, so there is a vertical compression. It moves to the right 3 units, and it moves up 2 units. Okay, so, okay, Izzy, where is the vertex gonna be for this?
At
3 comma 2. Okay, so go ahead and plug this in, right? Did you plug it in?
like for you, I start with that and then I go up to and then
Yeah.
Okay.
Mm-hmm.
And then I push it.
Mm-hmm. Okay. Yep. Yes, honey.
I thought like you go to the you go up.
4 per seat.
Yeah.
I'm just gonna tell you the points, right?
Yeah.
I got 1,4.
1,4.
Yeah. 1,4.
Yeah. Okay.
And then I got 5.
Right. So take a look at this one. So at x equals 1, it's 4, right? Now, how many is it away from this? It's 2 away. So here I put that on that side as well, right? So I get a parabola that looks like that. Okay. All right. So quickly, let's go ahead and graph the next one on the calculator, right? So the transformations are left 4 units. Yes. Down 6 units. There is a vertical stretch, and what else? There is one more. Reflection around the x-axis. So if we go left 4 and down 6, here's where the point will be for the vertex, right? So I do Control T, and now, okay, so I want to plug in like either -5 or -4. So I go up here. I'm sorry, not -4, but -3 or -5, right? Do you see how -3 and -5 have the same y value, right? And those are -8. Like this. And so that's how I graph. Okay? Any questions?